Hi, everybody. Welcome to another Chats with Chaudhry. I hope you're safe and well. Today, I'm delighted to be joined by a repeat guest, actually. I'm delighted to be joined by Gordon Hamilton, who is the president, CEO, and co-founder at Depixus. And Gordon and I actually caught up. God, it must be more than a year now, Gordon.
Yeah, absolutely.
When he originally talked about the MAGNA technology. So we're going to get an update on what's been happening at Depixus and also the MAGNA technology. So first of all, Gordon, it's lovely to see you. How are you?
Yeah, it's great. And great to be back in touch with Sven. Yeah, super. Yeah.
Well, it's a long time since we last spoke. Now, where are you calling in from?
So based here in Paris.
All right. Well, hopefully everything is okay in Paris at the moment and nice and calm.
We're doing it's all right. Things are settling a wee bit, which is good.
Yeah. Well, I'm glad to hear it. Right. Now, I know you and I spoke before, but for people who are not familiar with Depixus, then would you mind just giving viewers a quick overview of who you are as a business and also what you do?
Sure. So we're a French company based here in Paris, venture backed, and we're developing. So we're a life sciences tools company and developing tools specifically to be able to look at biomolecular interactions, how biological molecules interact with each other, and to provide some very detailed view into how molecules interact, and that really is at the heart of biomolecular science, is understanding the dynamic world of molecular interactions that are happening within inside cells across all forms of life.
All right. Well, let's talk a bit more about MAGNA then. So in terms of the platform itself, can you tell me a bit more about how it works and what makes it unique to other technologies out there?
Yes, so a lot of there are obviously many technologies out there for looking at biomolecular interactions, and both in fundamental research science and of course in pharmaceutical drug development science, being able to look at how molecules interact with each other is pretty critical and important. But most technologies today are limited in certain dimensions. Often what technology is doing are either taking a snapshot in time of molecules interacting with each other, so they're taking really a photo of an almost instantaneous moment of an interaction occurring, if all goes well. Or alternatively, they're technologies that are able to look at interactions that are happening in bulk. In other words, looking across many interactions and looking at average data across those interactions. And what we're doing at Depixus is trying to develop but we're developing and soon to be launching a technology which can allow the users to have a real-time view, sort of a bit more like a video camera, if you like, real-time view of individual interactions occurring, and to be able to do that across many interactions in parallel. So we have multiple data streams coming off the instrument system, again, that allows to look at those individual molecular interactions as a sort of almost like a video feed, if you wish.
Right. Okay. Well, look, let's look at that a bit more, because you mentioned MAGNA is able to unpack those complex molecular interactions. So, and you mentioned, I know, some of the limiting factors. What is really limiting the progress in this area?
So again, I come back to what I've really just said, that having a really detailed view allows us to go right to the heart of interactions themselves and understanding those interactions. So again, huge amounts of data out in the literature coming from existing technologies, looking at molecular interactions in bulk or looking at these very fine detail snapshots in time. But what we really want to try to help the research and pharmaceutical community to better understand what of all that data is real, and what of that data can be used to ultimately understand disease mechanisms better, and to be able to generate and develop new and more effective next generations of therapies. And I think it's really that detailed so-called single molecule view into molecular interactions, getting to the heart of the interaction, that will allow that to be possible.
Right. And how is MAGNA going to solve this problem then?
Well, I think it's probably best described, and by way of an example. First, to answer your question around, how does in effect, your question is, how does the technology work? So this is based around a technology known as magnetic force spectroscopy.
Right.
So it is an instrument system that allows us to capture molecules on the floor of a flow cell, and to use magnetic force to be able to look at the strength of biomolecular interactions as they occur, and to see how those biomolecular interactions are either stabilized or destabilized by other molecules. So it could be, for example, a drug that is coming in to destabilize an RNA. So by way of an example, one of the big sort of new hopes in drug development is to be able to go after targeting RNA molecules. Of course, traditionally, drug development has been focused on proteins and drugging proteins, but RNA is seen as this very, very exciting new class of drug target, because there's a lot of the protein world which is undruggable for a variety of reasons that we don't necessarily need to go into. But so RNA is seen as a way to be able to target those undruggable proteins, or to target mechanisms which are involved in the fine regulation of gene expression.
Right.
So RNA is an exciting target, and RNAs can form complex structures, secondary and tertiary structures, and there's a big move to develop drugs that target RNA,
Sure.
and a big move to develop small molecules that target these RNA structures. Now, these RNA structures, it's got similarities with proteins, but they're often very, very dynamic structures. They change a lot.
Right.
One RNA structure can have multiple different conformational states. And so taking a snapshot in time, to come back to what we were talking about earlier, that snapshot in time, you may only get a view of an RNA which is in one particular conformational state. It may not even be the biologically active state. And to be able to look in real time at a single molecule level about how a molecule's changing dynamically between different conformations, when a drug is binding to it, in which conformational states, that's a really powerful new view into that world of drug development that really is not open to the research or pharmaceutical world with existing technologies.
Right. Okay. Now, obviously, you said you're going to be launching this in the not too distant future.
Yeah, it's coming up. It's exciting.
So what do you see the future for this technology?
So we'll be opening up a beta program for some early beta testers in the second half of this year, towards the end of the year, and then there'll be an early access program launching sometime probably towards the end of the second quarter of next year. So it's an exciting time. First time we'll get the instrument system outside of our labs and properly into the hands of collaborators. So we see two main areas of use. I kind of alluded to that in perhaps in what I've said. The first is into academic research labs, where better understanding the world of biomolecular interactions brings us towards a better understanding of disease mechanisms, fundamental biology, and so on. But really, where the tool is particularly powerful is in helping the pharmaceutical industry to better understand how drugs are binding to their targets. Firstly, target selection. So are we going after the right targets? Again, to use the example of RNAs, are we picking suitable RNA structures?
Right.
Do we understand what those structures look like, their different conformational states? And then are we developing the right drugs to target those structures?
That's good. It's very exciting stuff then. So obviously, if people want to learn more though, where can they physically see the technology in action? And if they can't do that, where else can they get more information?
So as part of the beta program, or at least alongside the beta program, we'll also be launch, sort of, as it were, giving the technology more visibility at a variety of conferences in the second half of this year, and also on into next year. We'll certainly be at SLAS, for example, early next year, which we're very much looking forward to. So that's a very good, if we can cross paths at various conferences over the course of this year and into next. All the details of which conferences we'll be at will be on our website, and it'd be great to meet people and to open up some discussions about how they might be interested to use our technology in the future. And of course, as I've just said, our website is a very good source of information on the technology itself, and gives folks a route to be able to contact us to learn and understand more about the technology.
Brilliant. Well, there you go, viewers. If you'd like to learn more from Gordon about the MAGNA platform, then you can get in touch with him via LinkedIn. Leave some comments below the video, and obviously there will be numerous events. And in fact, rather than Gordon having to remember the events, I'm going to put them up on the LinkedIn post so you can actually see which events they're attending. But obviously you can check out their website page to find out more about which events they're going. But as Gordon quite rightly said, they're going to be at SLAS in February next year, and many others, including, I think it's the Hanson Wade Assay Development Screening Summit in August as well. So I've actually got the list in front of me, which is why I'm reading them out. Gordon doesn't, so that makes it a bit easier for him. So it makes it a bit easier for me. But if you'd like to know more though about Depixus and the technology, and maybe get involved in sort of beta testing it as well, then get in touch with Gordon. I'm sure he'll be happy to hear from you, and we can go from there. So Gordon, good luck with the roll. I hope the launch goes really, really well, and the testing carries on to be successful for you. And hopefully we can catch up in person at an upcoming event as well.
That'd be great. Yeah, it'd be super.
I look forward to it. But viewers, there you go. If you'd like to know more, check out the website, check out the LinkedIn page, meet the team at the numerous events they're going to be at throughout this year and into next year. And if you've got any questions to say, leave them below. So Gordon, thanks for your time. And viewers, thank you for watching. Until next time, as always, stay well and stay safe. Bye-bye.